This is Sintra, a production-ready Flutter starter kit that helps you ship faster with a clean, feature-first structure, built-in code generation, localization, and thoughtful docs. All guides live in the Docs folder for quick answers. Let's peek at project structure. A clear feature-first layout, shared foundations in core, a template that keeps each feature self-contained, easy to navigate, scalable, and a dev sandbox, which shows real usage of theming, localization, forms, and images. The features live here. The template scaffolds data layer with a simple, clean, solid approach, and presentation layer for UI and business logic. Solid localization flow lives here. Core holds the shared building blocks, a robust error pipeline, helpful extensions, and forms inputs with localized validation, keeping features lean and consistent across your app. Dependencies are sensible defaults, block, screenutil, localization, and tooling out of the box. Sintra is structured, documented, and production-ready. Start simple, then scale confidently. Features stay modular, code stays readable, and your path to shipping stays fast. Let's zoom into the feature template. Inside data, we keep data sources, models, and repositories. Inside presentation, we keep qubits, where the business logic lives, and screens, which includes the feature's UI entry point. And finally, the barrel exports. Let's check the template's README. It links straight to the feature template guide. It reinforces the same structure you're seeing and shows how to extend it safely, with screens exported and internals encapsulated. Plus a note on using CodeGen to scaffold fast. CodeGen is the magic of Sintra. It's a built-in tool to generate features and qubits for your needs. Speaking about that, let's look at the built-in tools. That's where the CodeGen reside. Under Generators, you'll find the qubit and feature generators. Under Templates, the qubit and state blueprints they emit. Utils ensure CLI's clean placement. Let's dive into the CodeGen documentation and see how it works in practice. The CodeGen docs show the commands. Dart run CodeGen for the menu. Dart run CodeGen followed with feature or qubit for specific choice. We'll run the command and watch files appear live. Terminal at the bottom, features on the side, docs in the center. Let's try the menu first. As the documentation says, in the terminal we type Dart run CodeGen. The menu offers two generators, feature and qubit. I'll pick feature and name it test. The folder appears with data and presentation ready to fill. So let's first enter a random name for local data source. Then a remote data source. Add a model called mod. Add a repository named repo and a qubit named cub. The generator wires everything up and reports success. Under test, you can see data sources, models, repository, and presentation. Opening the generated qubit shows the standard boilerplate that fits the kit's patterns. The state pairs with the qubit for clear updates and testing. That's the entire feature scaffold, done in seconds and ready to extend. Sintra has cool theme system. Under Style is the theming stack, config, and theme qubit for app-wide mode. Here's theme qubit, clean, commented logic that manages mode and updates the UI. The Dev Sandbox has a theme example with a ready demo screen. Everything is built in clean and user-friendly approach, following the principles of the project structure. Let's watch live demo. From Home, tap Theme. Here's a live overview of the design system theme mode, a cohesive color scheme, and the full typography scale so you can judge contrast and hierarchy at a glance. Disable follow system. Switch to dark. Back to light. And dark again. Instant app wide. Re-enable follow system. It snaps to light. Turn it off, choose dark, and go back. Theme applies everywhere. Sintra's theming is simple, extensible, and consistent across the entire app. Let's see localization in action. It lives under lib and includes locale state, ARB resources, and the translation wiring. LocaleQubit manages the active locale and emits updates to rebuild the app. Clear comments make changes straightforward. Strings live in ARB files per language. Keys stay consistent while values change per locale. These feed flutters Gen L10N, producing app localizations for type-safe access. The L10N setup ties delegates and supported locales, and exposes app localizations for type-safe lookups. The Sandbox ships a localization demo. The screen code is lean, with small widgets for clarity. Now let's preview it live. Here you can pick a locale, and a live preview below reflects the result immediately. Selecting Arabic applies instantly and flips layout to RTL. On home and different screens, you can see the entire app perfectly localized. You can hop between English, Arabic, and Turkish, or the device default, and watch text and direction update across the app in real time. Let's see Sintra's custom lints. Under Tool, Lints is the project's custom lint plugin. In AppLints.dart, we wire rules and their one-click quick fixes. Directional rules catch left/right pitfalls, padding, alignment, and text, nudging you to use directional start/end for RTL-safe layouts. In PubSpec, lints are set as dev tools. Flutter lints for the base. Custom lint, plus our local plugin, tool/lints. Here in Analysis Options, you can enable, disable, or tune severities so checks fit your workflow without getting in the way. Let's try one live in the Sandbox to see the quick fix improve consistency and speed. I am going to paste code using left/right padding and center-right alignment. Let's see what would happen. The analyzer flags two issues: use directional start or end instead of left or right, and alignment directional start or end instead of left or right variance. And now, let's see the magic. Quick Fix offers two conversions. Assume LTR or RTL. I'll choose LTR. Padding converts to directional start end automatically. Next fix. RTL. Alignment becomes alignment directional center start. And now, let's walk through images. Let's preview the example screen. We'll deal with all types in one place. The magic happens with our solid defined AppImage type. AppImage is a single typed model for images from any source. It's a simple SOM type with helpers and a when dispatcher, so the UI handles asset, file, and network uniformly. Fewer branches, safer code. Speaking on that, let's see a built-in shared widget that use it under components. Custom Image is the drop-in widget that renders an app image, with sizing, shape, and placeholders baked in. So the whole point is one component, consistent behavior, any source. Inside, it switches on the source, asset image, file image, or cache network image, with a lightweight loading state so every path feels identical to use. Let's have a look to the sandbox image example. As always, the structure reflects the project's engineering principles. Qubit wires user actions to an app image value, and, when needed, to the pick and crop flow through the repo, keeping UI dumb and logic predictable. The pick and crop flow lives under modules, and modules in Sintra act like reusable features you can share across the app. The image pick crop module wraps the full select then crop experience behind a clear API. Data sources talk to the platform pickers and cropper. Helpers handle transforms. Models capture pick and crop different options. And the repository orchestrates the sequence so your feature code stays tiny. Now let's try out everything. Asset image shows immediately. Let's try pick and crop. From gallery, we select an image. Open the cropper. Rotate once. And hit done. The result appears instantly. Camera works on device, but I'm on simulator. Network loads with caching and a placeholder. Remove clears back to no image. Together, app image, custom image, and the pick and crop module give you a unified, dependable image pipeline, and everything is documented perfectly in the project. Let's jump into forms, validation, and real error flow. Sintra's inputs are forms models built on a shared base. Each input validate values and show localized errors as you type. Examine Sintra's error handling mechanism. Data sources throw app exceptions only vendor agnostic and never user-facing. Repositories translate those into a typed failure the UI can show. Error info holds the code and the localized message used on screen. Error mapper does the exception to failure mapping in one place. In Dev Sandbox, the form example is a full mini feature, a fake data source with a fixed delay. When the email equals fail at demo.dev, it throws a fake exception that the repository handles. The request model is a tiny data class, clear fields plus to map and from map. The repository is the translation point, success or exceptions in result is the output. The qubit tracks each form's input and submission status. Tips at the top. Fail at demo.dev triggers the error path deterministically. The screen wires fields, validation, and a submit button. Listeners show loading, then success or error dialogues. Let's see that in practice. I will insert a name, and you can see. As I type, auto-validation kicks in. Invalid input shows a short localized hint beneath the field. Switching locale to Turkish. The same validation hints appear in Turkish. No code changes. Let's fill the form. At this stage, we need to simulate success, so any email other than fail at demo.dev can pass. Submit shows a localized success dialog, fast, predictable flow. Now let's try the failure path. It is already localized, but I'll pick English for clarity. Filling the form again, but this time in order to simulate errors handling, we'll insert fail at demo.dev in the email field. We'll touch the smooth flow, where the data source throws, the repository maps to failure, the qubit sets status.failure, and the UI shows a clear, localized error dialog. That's the full flow. Forms inputs become a result, then a dialog. Clean, testable, and localized. To wrap up, here's Sintra's backbone in action. This is app.dart, the kit's hub. Theme and locale qubits initialize early. Screen util sets design size and scaling. Block selectors feed material app with theme and locale. App localizations provide strings. In Sintra, every area ships a quick README pointer. Let's pick random one. Here's the feature template for example. The quick link directs to its documentation under Projects Docs. The guide explains the feature-first shape, data, and presentation layers, plus a note about the code generator. The docs are comprehensive: code generator, dev sandbox, engineering principles, errors, forms, localization, theming, modules, responsive layout, and custom lints. Short, practical, consistent. Every topic has a home, easy to find and easy to trust. The root README mirrors the essentials and links straight into docs. Here's the project structure at a glance. Sintra starts fast and scales. Feature-first structure, code generation, internationalization with right to left, solid error handling, responsive UI, and clear docs.